Alright, so in this problem, I have a squared minus b squared is equal to 19. So I want to note that a and b, these are both positive integers. And we want to find the value of a and b. So, to start, we first start with a squared minus b squared is equal to 19. Now, we can use logic to deduct some information. So if a squared minus b squared, if this is equal to 19, then this must mean that a minus b is greater than 0, meaning a is greater than b. Because let's say a was less than b. So let's say a is 1 and b is 2. So now I have 1 squared minus 2 squared is equal to 19. Well, 1 squared is 1 minus 2 squared is 4. And this is actually going to be a negative number. But as you can see, a squared minus b squared, this is a positive number. And the only way for this to be a positive number is if a is greater than b, because if b is greater than a, then this would be negative. So now if I have something in the form x squared minus y squared, this is simply equal to x plus y times x minus y. So in this case, we can think of a as x and b as y. So this would be equal to a plus b times a minus b, which is equal to 19. Now 19, this is equal to 1 times 19, right? These are the only two factors of 19 because 19 is a prime number, meaning its only factors are 1 and itself. So we can actually think of a plus b as 1 and a minus b, we can think of a plus b as 19 and a minus b as 1. Because if we correlate 1 with a plus b, if we correlate 19 with a plus b and 1 with a minus b, then we get 1 times 19, which is equal to 19. So now that we know this, we know a plus b is equal to 19 and a minus b is equal to 1. We can simply solve for a and b because this is a system of equations. So if a minus b equals 1, I'm going to add b on both sides and subtract 1 on both sides. So then these two cancel out and I'm going to be left with a minus b is equal to, a minus 1 is equal to b. So now I can go ahead and plug this into my original equation. So now I have a plus a minus 1 is equal to 19. A plus a is 2a, so I have 2a minus 1 is equal to 19. If I add 1 on both sides, I get 2a is equal to 20, meaning a is 10. So if a is 10 now, then this means that I simply have to plug into one of these equations. So if a minus b is equal to 1, a is 10, so I have 10 minus b is equal to 1, meaning b is 9. So a equals 10 and b equals 9. These are my answers. Alright, so in this problem, I have 9 to the power of 9 divided by 9 to the power of 9 divided by 9 to the power of 9 divided by 9 to the power of 9. So what I'm first going to do is I'm going to simplify this in parts. So let's first simplify 9 to the power of 9 divided by 9 to the power of 9. Well, 9 to the power of 9 divided by 9 to the power of 9, that's simply just 9 to the power of 9 over 9 to the power of 9. So I have this divided by 9 to the power of 9 divided by 9 to the power of 9. Now, remember, we have to go in order because remember, PEMDAS, we would have to go in order. So we can't just simply switch these out. We can't just do this divided by these two. We have to go in order. So what comes first is 9 to the power of 9 divided by 9 to the power of 9. So anything divided by itself is 1, so these two cancel out, and I'll be left with 1 divided by 9 to the power of 9 divided by 9 to the power of 9. Now again, you would have to go in order now. So now we're going to do 1 divided by 9 to the power of 9. So 1 divided by 9 to the power of 9, this is equal to 1 over 9 to the power of 9. Now I have this divided by 9 to the power of 9. Now, if I have something in the form 1 over a to the power of n, this is the same thing as a to the power of negative n. So 1 over 9 to the power of 9, that's going to equal 9 to the power of negative 9. Now I have this divided by 9 to the power of 9. So now, let me clear out this page. I have 9 to the power of negative 9 divided by 9 to the power of 9. Now, this is the same thing as 9 to the power of negative 9 over 9 to the power of 9. And now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 9 to the power of negative 9 over 9 to the power of 9, this is going to equal 9 to the power of negative 9 minus 9. And negative 9 minus 9, that's simply equal to negative 18. So now I have 9 to the power of negative 18, which is equal to, well, 9, this is the same thing as 3 squared. So I have 3 squared to the power of negative 18. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So, three to the power of 2 to the power of negative 18, this is going to equal 3 to the power of 2 times negative 18. And 2 times negative 18 is negative 36, so I have 3 to the power of negative 36, which is equal to 1 over 3 to the power of positive 36. So this is my answer. Alright, so in this problem, I have 6 divided by 2 times 1 plus 2. And this is actually a very simple algebraic problem that many people actually get wrong. So to solve this, what I'm going to use is PEMDAS. PEMDAS. So the P here, this stands for parentheses, the E stands for exponents, the M stands for multiplication, the D stands for division, the A stands for subtraction, and the A stands for addition, and the S stands for subtraction. So we have to go in a certain order. So what we first start with, we start at the top, and we first look for parentheses. So if something is in parentheses, we solve that first. Well, as you can see here, 1 plus 2, this is in parentheses. So 1 plus 2, that's equal to 3. So now I have 6 divided by 2 times 3. And 2 times 3, this is written like this. Next, well, again, now, we again look for parentheses. There are none. So now we go down. We go down to exponents. Are there any exponents here? No, there aren't. So now we're going to go down to multiplication. And for multiplication and division, although it's written like this, these two are actually in the same box. And same goes with addition and subtraction. So whichever one out of these two comes first, multiplication or division, that's the one that you're going to start with. So right here, as you can see, going from left to right, we have division, meaning we're going to use that first. So now I have 6 divided by 2, which is equal to 3. So now I have 3 times 3, and now all we have left is multiplication. 3 times 3 is 9. So 9 here would be our answer. Now, what people used to do to get the wrong answer actually is, this was actually during the 1900s, what they would do is they would use the right method. They would first start by adding 1 plus 2 in the parentheses, so this would be equal to 6 divided by 2 times 3. But now, instead of doing 6 divided by 2, they would do 6 over 2 times 3. And 2 times 3 is 6, so they get 6 over 6, which is equal to 1. And this is actually the wrong method, because as we know, we do between multiplication and division, we do whichever one comes first. So in this case, division comes first, so we would do that before the multiplication. So that's how you solve this problem. Alright, so in this video, I'm going to be solving the problem 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And for this problem, I actually have 4 option choices. So for A, I have 27 to the power of 30. For B, I have 9 to the power of 30. For C, I have 27 to the power of 10. And for D, I have 3 to the power of 21. So to first start out, let's go through all these option choices and see if they're right or not. So we first have A, 27 to the power of 30, and how this likely was resulted in was from adding all the bases and adding all the exponents. So we have 9 plus 9 plus 9 to the power of 10 plus 10 plus 10, which is equal to 27 to the power of 30. And this is actually wrong because this is not the proper way to add exponents. So now going from here, this was likely gotten, 9 to the power of 30, by keeping the base the same and then adding the exponents. And this again is wrong because this is not the right way to add exponents. Now we have 27 to the power of 10, and this was gotten from adding the bases, but keeping the exponent the same. And this, again, is wrong as well. That's not how you add exponents. Now, 3 to the power of 21, which is by process of elimination the right answer, we're going to see how they got this. So we first start with 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I'm going to factor out 9 to the power of 10. So I get 9 to the power of 10 times 1 plus 1 plus 1, which is equal to 9 to the power of 10 times 3. And now this is equal to 3 squared to the power of 10 times 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 10 is going to equal 3 to the power of 20. And I have this times 3 to the power of 1. So I simply just add the exponents. This is equal to 3 to the power of 21. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family members.